Every atom in your body was once part of a star that lived and died long ago. That's not poetry, it's science. The stars above aren't just beautiful, they're the reason we exist. We are literally made of star stuff. Ancient civilizations worshipped them. Today, we know stars are born, they burn, and they die in explosions so powerful they reshape galaxies. So when you look up tonight, ask yourself, what are you really seeing? A light show, or the history of everything? Let's uncover the life and death of the stars and why their story is also ours. The birth of a star. Stars are born in the cold, dark expanses of space within massive clouds of gas and dust known as nebulae. Imagine these nebulae as vast cosmic nurseries where the ingredients for new stars are scattered across the universe. These clouds contain the raw materials, hydrogen, helium, and dust particles, that, when compressed under the immense force of gravity, can give birth to something incredible. Gravity is the star's first catalyst. It slowly pulls the gas and dust together, causing the particles to collide and condense, making the cloud denser and hotter. This process takes thousands to millions of years, depending on the size of the nebula. As the gas and dust compress, a new hot and dense core forms at the center called a protostar, but it's not quite a star yet. The protostar is still in the process of gathering mass and energy. The temperature and pressure inside this core continue to rise, and once they hit around 15 million degrees Celsius, something incredible happens. Nuclear fusion ignites. This is the moment when a star is truly born. Hydrogen atoms in the protostar's core start to fuse into helium, releasing vast amounts of energy. This fusion creates light and heat, causing the star to shine brightly. And just like that, a new star is lighting up the cosmos. The process continues, and as the star stabilizes, it enters the main sequence phase, which can last for billions of years. Stars may begin from the most ordinary of elements, but through the forces of gravity, pressure, and time, they evolve into shining beacons in the night sky, marking the birth of something far greater than just light. It's the beginning of a stellar life cycle that will span millions, sometimes billions of years. Main sequence. After a star is born and nuclear fusion takes hold, it enters what we call the main sequence phase. This is the star's stable period, where it spends the majority of its life. Think of it as the star's middle-aged phase, where everything is calm, stable, and most importantly, shining. The star is constantly fusing hydrogen atoms into helium in its core, a process that releases an incredible amount of energy. This energy is what powers the star and gives it its brilliant light. For a star like our Sun, the main sequence lasts for about 10 billion years. That's right, a star is in this phase for a very long time. During this phase, the star has reached a perfect balance. On one side, the energy produced by nuclear fusion creates outward pressure, which tries to expand the star. On the other hand, gravity pulls inward, trying to collapse the star. These two forces, gravity and fusion, counterbalance each other perfectly, keeping the star stable and glowing. For most stars, this is the longest period of their lives. They shine steadily, providing light and heat to their surrounding planets, and if they're lucky enough, they might even give rise to planets with life, like Earth. The main sequence is an incredibly important phase in the life of a star. It's during this time that stars reach their full luminosity, and for us on Earth, it's what allows the stars in the night sky to shine brightly. But just like every good thing, the main sequence phase must eventually end. But before we dive into what happens when the star runs out of fuel, let's just take a moment to appreciate this balance that makes stars like our Sun such essential players in the cosmic drama. This phase represents the peak of a star's vitality, and without it, the rest of the stellar journey wouldn't even be possible. Red giant phase. As a star like our Sun enters the later stages of its life, its hydrogen fuel in the core begins to run low. But don't think that means the end is near. This is just the beginning of one of the most dramatic changes a star will undergo. When the hydrogen runs out, the core starts to contract under gravity's pressure, and in response, the outer layers of the star begin to expand, cool, and take on a reddish hue. Welcome to the red giant phase, where the star grows into a colossal, glowing sphere. At this point, the star's core is much hotter than before, which allows the fusion of heavier elements like helium. As helium atoms fuse together, they form carbon and oxygen, and the fusion process generates even more energy. This energy causes the outer layers of the star to expand massively. In fact, a red giant can grow to be hundreds of times the size it was during its main sequence phase. If our Sun were to go through this stage, it would expand so much that it could engulf Mercury, Venus, and even Earth. Imagine our planet, once teeming with life, now being swallowed by a massive red-hot ball of gas. But even as the star swells in size, things are beginning to change beneath the surface. The increased temperature causes the outer layers to become unstable, leading to massive stellar winds that blow away the star's outer material. In some cases, these winds can carry away up to a third of the star's mass. As the star grows, it starts to shed its outer envelope, leaving behind a dense core. This core will eventually become what's known as a white dwarf, the next phase in the star's journey. While this red giant phase might seem chaotic, it's actually one of the most fascinating stages in a star's life. The transformation from a stable, burning furnace into a massive, unstable behemoth is an awe-inspiring sight. And it's during this time that some stars make their most significant contributions to the universe, creating the heavier elements needed for future star systems and planets. Supernova explosion. For stars that are much more massive than our Sun, the red giant phase is just the beginning of a fiery and explosive end. These stars, once they have exhausted their core hydrogen, undergo a more dramatic and intense series of events that lead to the birth of one of the most magnificent phenomena in the universe, the supernova. But how does this happen? It all starts when the core of a massive star starts fusing heavier elements like carbon, neon, and oxygen into even heavier elements like iron. However, when the core finally forms iron, something changes. Unlike lighter elements, iron cannot undergo fusion to release energy. This creates a major problem for the star. Without the energy from fusion to counteract gravity, the core begins to collapse. The pressure from this collapse causes the outer layers of the star to implode inward at incredible speeds. As the outer layers crash into the dense core, they are thrown outward in a cataclysmic explosion. This is a supernova, a violent, explosive event that releases more energy in a single burst than our Sun will release throughout its entire lifetime. The explosion is so powerful that it can briefly outshine an entire galaxy. During this brief period, the supernova becomes the brightest object in the sky, visible across vast distances. These explosions scatter the star's outer layers into space, enriching the interstellar medium with heavy elements like gold, uranium, and iron. Elements that are crucial for the formation of planets, life, and everything we see around us. Supernovae are essentially the universe's recycling process, creating new building blocks for future stars and planetary systems. But not every star dies the same way. While smaller stars will collapse into white dwarfs, the most massive ones undergo an even more fascinating fate: a neutron star, or, if the mass is great enough, a black hole. But before we delve into these stellar remnants, let's pause and appreciate the sheer cosmic power of a supernova. It's a spectacular end to a star's life and a beautiful beginning for the next generation of stars and galaxies. Stellar remnants. When a massive star explodes in a supernova, it doesn't just disappear into nothingness. What's left behind is a dense, compact remnant that is often more fascinating than the explosion itself. The fate of this remnant depends entirely on the mass of the star's core. There are two possible outcomes for the surviving core: a neutron star, or, if the core is heavy enough, a black hole. Neutron star. For stars with a core mass between roughly 1.4 and 3 times that of the Sun, the core doesn't collapse into a black hole. Instead, it becomes a neutron star, a celestial body so dense that its atoms essentially collapse into neutrons. A neutron star is incredibly small, with a radius of only about 10 kilometers, yet it packs more mass than our Sun. This density means that the star's gravitational field is extreme, and neutron stars are known to emit intense magnetic fields and fast-spinning beams of radiation, which we detect as pulsars. These pulsars can spin up to several hundred times per second, creating a cosmic lighthouse effect. Imagine the power of a star compressed into such a tiny, dense object. For stars with a core mass greater than about 3 solar masses, no amount of pressure can prevent the collapse. The core continues to shrink, becoming so compact that it forms a singularity, an infinitely small point with immense density. This process creates a black hole, a region of space where gravity is so strong that not even light can escape. A black hole doesn't suck everything around it like in the movies, but its gravitational pull is so strong that anything that ventures too close gets pulled in, never to escape. Black holes are mysterious and elusive, but they play a crucial role in shaping galaxies, as most large galaxies have a supermassive black hole at their center. These objects are both fascinating and terrifying, and we can only begin to imagine the mysteries they hold in the depths of their gravity wells. White dwarfs. While the fate of massive stars is marked by dramatic explosions and mysterious remnants, the path of smaller stars, those with less than 8 times the mass of our Sun, is equally fascinating but less violent. Instead of blowing up in a supernova, these stars end their lives as white dwarfs. For stars like our Sun, the transformation into a white dwarf is a quieter, more gradual process, but no less important in the cosmic cycle. When a star like our Sun runs out of hydrogen fuel in its core, it begins to shed its outer layers, releasing a glowing shell of gas and dust known as a planetary nebula. What's left behind is the core of the star, which becomes the white dwarf. A white dwarf is a small, dense object about the size of Earth, but with a mass comparable to that of the Sun. This incredibly dense remnant is made primarily of carbon and oxygen, supported against further collapse by electron degeneracy pressure, a quantum mechanical force that arises from the Pauli exclusion principle. In simple terms, this pressure prevents the electrons in the white dwarf from being squished together. Over time, white dwarfs slowly cool and fade, becoming dimmer and dimmer over billions of years. Eventually, they will no longer emit any light or heat, leaving behind a cold, dark relic of the once glowing star. These white dwarfs are not completely lifeless, though. In fact, the elements they contain are some of the building blocks for new stars, planets, and even life. The cosmic recycling process continues as the white dwarf's remnants, its carbon and oxygen, might eventually become part of a future generation of stars or planets. Even in death, the star has a profound impact on the universe, passing on the elements needed for new life to take shape. Stars with lower mass end their lives not with a bang, but with a whisper, a slow, silent fade into the cosmic background. But even in their quieter demise, they play a vital role in the ongoing creation of the universe. The cosmic recycling. The death of a star, whether through a supernova explosion, the slow fading of a white dwarf, or the quiet collapse of a neutron star, is not the end of the story. In fact, it's only the beginning of a new chapter in the universe's vast and ongoing cycle of creation and destruction. The elements that were once forged in the heart of a star, hydrogen, helium, carbon, oxygen, iron, and more, are scattered throughout space, enriching the interstellar medium and becoming the building blocks for the next generation of stars, planets, and even life. When a massive star dies in a supernova, the explosion blasts these elements into space at incredibly high speeds, often faster than the speed of light. This cosmic spray of material can travel across vast distances, carrying with it the very elements that are essential for the formation of new stars and planets. For example, our own solar system was likely formed from the remnants of earlier supernovae. The heavy elements that make up the Earth, including the iron in our cores and the oxygen in our atmosphere, were born from the death of ancient stars. Without these stellar deaths, life as we know it would not exist. But it's not just supernovae that contribute to this cosmic recycling process. White dwarfs, the remnants of medium-sized stars, also play a role in this cosmic game of life and death. Over time, as white dwarfs slowly cool and fade, they might still release their residual elements into the surrounding space. These elements could be incorporated into new star-forming nebulae, further fueling the creation of new stars and planets. Moreover, neutron stars and black holes, while seemingly the ultimate end for a star, are not entirely disconnected from the cycle of stellar creation. For example, neutron stars can emit strong bursts of radiation known as gamma-ray bursts, one of the most powerful phenomena in the universe. These bursts of energy can trigger the formation of new stars in distant regions, essentially reigniting parts of the galaxy into new life. Even black holes, with their immense gravitational pull, can influence the formation of new stars by pulling in nearby gas and dust, providing the necessary material for star formation in a process known as accretion. Thus, the death of a star is not a solitary event, it is an essential part of a greater cosmic cycle. Each time a star dies, it releases the ingredients for new beginnings, new stars, new planets, and potentially even new life. The universe, it seems, is forever recycling itself, and each stellar death is a crucial step in this ongoing process of creation. The birth and death of stars are, in a sense, two sides of the same coin, forever linked in the vast, ever-changing tapestry of the cosmos. Thanks for joining me on this incredible journey through the life cycle of stars. From their dramatic births in swirling clouds of gas to their spectacular deaths that seed the universe with new elements, stars truly shape everything around us. The next time you look up at the night sky, you'll see more than just points of light. You'll see stories of creation, destruction, and cosmic rebirth. Stay curious, keep looking up, and keep wondering about the vast universe we call home. And if you love discovering the secret of the universe, don't forget to like, subscribe, and hit the bell icon for more adventures. NASA's recent discoveries deep within the sun's core are rewriting our understanding of the star that sustains life on Earth. Using cutting-edge missions like the Parker Solar Probe and the Solar Dynamics Observatory, scientists have unveiled astonishing phenomena, from massive magnetic tornadoes to mysterious plasma tsunamis, that reveal the sun's inner workings are far more dynamic and dangerous than ever imagined. One powerful fact stands out: the sun loses 4 million tons of mass every second, a relentless countdown to its eventual demise. The sun's secret nuclear furnace. NASA's latest data has revealed surprising new insights about the sun's core, challenging long-held beliefs. Traditionally, scientists thought the sun's energy output was stable, fueled by steady hydrogen fusion. However, recent findings suggest the core behaves unpredictably, exhibiting what researchers are calling fusion bursts. These bursts are violent, explosive events deep within the sun's 27 million degree center, unlike the familiar solar flares that occur on its surface. These fusion bursts are powerful enough to challenge existing physics models. Remarkably, the sun seems to hide these internal explosions by bending light, making them invisible to direct observation. If one of these bursts were to break free from the core's containment, it could have catastrophic effects on Earth, potentially collapsing our planet's magnetic field within 12 hours. This magnetic shield protects us from harmful solar and cosmic radiation, so its loss would be devastating. NASA warns that this behavior is abnormal for a star of the sun's age and stability, suggesting the sun might be undergoing unexpected internal changes. While this doesn't mean immediate danger, it raises important questions about our star's future and the need for continued monitoring. The solar vortex that defies physics. NASA's Solar Dynamics Observatory has observed massive swirling waves and vortices on the sun, including large-scale motions beneath its surface, but there is no verified evidence of a 300,000-mile-wide whirlpool inside the sun's core, spinning backward or causing time dilation effects. Research indicates the sun likely has polar vortices, rings of swirling magnetic patterns near its poles that evolve with the solar cycle and affect magnetic field reversals. These vortices form around 55 degrees latitude and migrate poleward, disappearing during solar maximum when the sun's magnetic polarity flips. However, these are surface and near-surface phenomena, not deep core vortices. The claim that such a vortex breaks fluid dynamics laws, causes time to slow, or threatens to tear the sun apart within a billion years, is not supported by current scientific data or NASA releases. The sun's core fusion processes and magnetic dynamics are complex, but remain consistent with established physics models. NASA has not publicly released or deleted data supporting such extreme assertions. The concept of a magnetic time warp or core vortex growing to catastrophic size appears speculative and unsupported by peer-reviewed research or official NASA findings. The sun's hidden black hole heart. There is no credible scientific evidence or NASA data supporting the existence of a microscopic black hole inside the sun's core. The idea that such a black hole, with the mass of a small moon but atomic size, lurks within the sun, contradicts established physics. According to current understanding, any microscopic black hole formed during the sun's birth would have evaporated long ago due to Hawking radiation. Gravitational anomalies and unexplained vibrations in the sun are actively studied, but they are generally attributed to complex plasma dynamics, magnetic fields, and fusion processes, rather than exotic objects like black holes. The sun's core is governed by nuclear fusion, which provides a stable energy output and prevents catastrophic collapse. The scenario of a black hole inside the sun triggering a hypernova is inconsistent with stellar evolution models. Our sun, a middle-aged star, is not massive enough to end its life as a hypernova. Instead, it will eventually become a red giant and then a white dwarf over billions of years. While the sun's core holds many mysteries, the black hole hypothesis remains speculative and unsupported by scientific evidence or NASA's observations. Ghost star inside our sun. So, there is no scientific evidence or NASA helioseismic data confirming that the sun consumed a twin star billions of years ago. The sun actually formed about 4.6 billion years ago from a collapsing cloud of gas and dust. And, well, while binary star systems are pretty common, our sun is understood to have formed as a single star. Helioseismology, which studies solar oscillations, hasn't revealed any chemical imbalances or elements that would indicate a consumed star inside the sun's core. The idea of a second magnetic field caused by the remnants of a twin star orbiting within the sun just isn't supported by current solar physics. The sun's magnetic activity and solar cycles are explained by the solar dynamo, a complex interaction of plasma flows and magnetic fields within the sun's convective zone. Variability in solar storms arises naturally from these processes without needing a trapped star, and the concept of a vampire star draining energy from planets is really speculative and not applicable to our sun's characteristics. While the sun's history and future definitely hold mysteries, the notion of it having devoured a twin star remains a hypothesis without observational backing or theoretical support. The sun's quantum abomination. So here's the thing. There's just no verified scientific evidence or NASA data backing up the claim that particles move faster than light near the sun's core, or that physics somehow breaks down in a 200-mile-wide zone there. According to established physics, nothing can travel faster than light in a vacuum. And causality, meaning cause comes before effect, is a fundamental principle upheld by Einstein's theory of relativity. Neutrinos produced in the sun's core do travel close to light speed, but they don't actually exceed it. The idea of time loops, miniature wormholes, or quantum anomalies causing gravitational ripples and atomic clocks skipping time all over the globe just doesn't have any observational or experimental support. And, honestly, no recorded event in 2012 or any other year has shown atomic clocks worldwide skipping 0.7 seconds simultaneously because of solar activity. While the sun's core is definitely extreme and complex, our current understanding still lines up with relativity and quantum mechanics. The sun does influence the solar system through gravity and electromagnetic radiation, but it's not testing or rewriting the fabric of reality. At the end of the day, these claims are pretty speculative and just aren't grounded in mainstream astrophysics or NASA findings. The sun's corpse-like core. When it comes to the idea of a corpse-like core, there's just no credible scientific evidence or NASA helioseismology data showing a 2,000-mile-wide dead zone in the sun's core where nuclear fusion has stopped. The sun's core is actually continuously sustaining nuclear fusion, converting hydrogen into helium and producing the energy that powers the sun and supports life here on Earth. Helioseismology, which is the study of solar oscillations, has not detected any region where fusion has ceased. Solar wind variations that have been observed since the 2000s are actually due to changes in the sun's magnetic activity and solar cycle dynamics, not because of a failing core or some kind of emergency backup power. The idea of a growing cold dead zone feeding on the core and mimicking fusion through electrical currents is, honestly, speculative and not supported by current astrophysical models. Sure, stars do change as they age, but the sun is stable and expected to keep its fusion processes going for billions of years. The whole concept of cancerous cold spots consuming a star from the inside just isn't recognized in stellar physics. While it's super important to keep monitoring the sun's behavior, claims about a dead core and imminent collapse within centuries really don't have a scientific basis and actually contradict what we know. The sun's doomsday protocol. Let's talk about the so-called doomsday protocol. There's absolutely no scientific evidence or NASA data supporting the existence of a kill switch called terminus inside the sun, or any star for that matter. The idea of a dormant magnetic weapon buried 150,000 miles beneath the sun's surface that could fire a relativistic plasma jet to sterilize solar systems is, well, purely speculative and just not grounded in astrophysical research. NASA's Parker Solar Probe is out there studying the sun's magnetic fields and solar wind, but it hasn't detected any signals that would suggest a self-destruct mechanism or countdown linked to ancient supernovae. The sun's activity cycles and magnetic behavior are explained by well-understood processes like the solar dynamo and magnetic field reversals. There's no need to bring in neural network-like filaments or cosmic railguns. The whole idea that stars have built-in self-destruct systems causing civilizations to go silent is really more science fiction than astrophysical fact. The sun's life cycle is governed by nuclear fusion and gravitational equilibrium, and honestly, it's expected to remain stable for billions of years before eventually evolving into a red giant, and then a white dwarf. So, in summary, the terminus kill switch narrative just doesn't have any basis in current solar physics or NASA findings. Thanks so much for exploring the sun's deepest secrets with Space Facts. If you found this journey into our star's core as mind-blowing as we did, don't forget to hit that bell icon so you never miss a cosmic update. Subscribe now to join our community of space enthusiasts, and drop a comment below. What discovery shocked you the most? Your thoughts really do fuel our mission to bring the universe closer to you. Stay curious and keep looking up. So, Earth's orbit around the sun isn't a perfect circle, it's actually an ellipse, which means our planet gets closer to the sun at some times and farther away at others. At perihelion, Earth is about 5 million kilometers closer to the sun than at aphelion, but surprisingly this doesn't cause the hottest or coldest seasons. Here's the striking punchline. Earth's seasons are driven more by its tilt than its distance from the sun. Did you know this fascinating fact before? What is perihelion? Well, Earth's orbit around the sun is far from a perfect circle. It's an ellipse, which means the distance between Earth and the sun changes throughout the year. One of the most fascinating points in this journey is called perihelion, the moment when Earth is closest to the sun. This event usually happens around January 3rd when the distance shrinks to about 147 million kilometers. At perihelion, Earth is roughly 5 million kilometers closer to the sun than at other times, which might make you think it's hotter then. But here's the twist. Perihelion actually occurs during the northern hemisphere's winter. This surprising fact reveals that Earth's seasons aren't driven by how close we are to the sun, but rather by the tilt of our planet's axis. Another interesting aspect of perihelion is that Earth speeds up in its orbit due to the sun's stronger gravitational pull, moving faster than at any other point in the year. This change in speed follows Kepler's laws of planetary motion, showing how gravity shapes our planet's path. While the extrasolar energy Earth receives at perihelion, about 7% more than at aphelion, does have some subtle effects on climate, it's not enough to override the seasonal changes caused by axial tilt. Understanding perihelion gives us a clearer picture of Earth's dynamic relationship with the Sun and helps scientists predict climate patterns and refine space navigation. It's a perfect example of how the cosmos operates with complexity and precision, influencing life on our planet in ways we're still uncovering. What is aphelion? Earth's orbit reaches its farthest point from the Sun at a moment called aphelion, occurring around July 4th each year. At this time, Earth drifts out to approximately 152 million kilometers away from the Sun, about 5 million kilometers farther than at perihelion. You might expect this distance to make summer cooler in the northern hemisphere, but surprisingly, it's the opposite. Aphelion coincides with the northern hemisphere's summer, reinforcing that the seasons are controlled more by Earth's axial tilt than by its distance from the Sun. Even though Earth receives about 7% less solar energy at aphelion compared to perihelion, this difference is subtle and overshadowed by the tilt's effect on sunlight angle and day length. Another intriguing fact is that Earth slows down in its orbit at aphelion, moving more leisurely due to the weaker gravitational pull from the Sun. This orbital speed change is a direct consequence of Kepler's laws, which describe how planets sweep out equal areas in equal times. The slower pace at aphelion slightly affects the length of seasons, making northern hemisphere summers a bit longer than winters. Aphelion also plays a role in shaping climate patterns, subtly influencing temperature variations and atmospheric dynamics. Understanding aphelion helps scientists model Earth's climate system more accurately and enhances our grasp of orbital mechanics. In essence, aphelion is a reminder of the elegant dance between Earth and the Sun, where distance, speed, and tilt combine to create the rhythms of life and weather we experience every year. Why does Earth's distance vary? Earth's orbit around the Sun isn't a perfect circle, and that elliptical shape is what causes the distance between Earth and the Sun to vary throughout the year. This variation is what creates the points known as perihelion and aphelion. But why does Earth's orbit take this shape in the first place? The answer lies in the gravitational forces exerted by the Sun and other planets, especially giant ones like Jupiter and Saturn. These forces tug and pull on Earth's path, stretching it into an ellipse rather than a circle. This elliptical orbit means Earth's distance from the Sun changes continuously, influencing not just the amount of solar energy we receive, but also the speed at which Earth travels around the Sun. Over thousands of years, these gravitational interactions cause subtle shifts in the orbit's shape and orientation, a phenomenon called orbital eccentricity. These changes can impact long-term climate patterns on Earth, contributing to cycles like the ice ages. Understanding the elliptical nature of Earth's orbit helps scientists explain why perihelion and aphelion happen when they do, and why the seasons don't line up simply with Earth's distance from the Sun. It's a complex cosmic dance shaped by gravity, momentum, and time, revealing how interconnected our solar system truly is. This knowledge not only deepens our appreciation for Earth's place in space but also improves climate models and space mission planning, showing that even the smallest orbital shifts can have far-reaching effects. Effect on Earth's seasons. Earth's seasons are often misunderstood as being caused by how close or far we are from the Sun, but the real driver is the tilt of Earth's axis. This tilt of about 23.5 degrees means that during different times of the year, either the northern or southern hemisphere leans toward the Sun, receiving more direct sunlight and longer days. Interestingly, Earth reaches perihelion, the closest point to the Sun, during the northern hemisphere's winter, while aphelion, the farthest point, occurs in its summer. This shows that the distance to the Sun plays a surprisingly minor role in seasonal temperature changes. Instead, the axial tilt controls how sunlight is distributed, creating the familiar cycle of spring, summer, fall, and winter. The tilt also affects the intensity of sunlight, making summers warmer and winters colder, regardless of Earth's varying distance from the Sun. However, the slight difference in solar energy received at perihelion and aphelion, about 7% more at perihelion, does have subtle effects on climate, such as influencing the length and severity of seasons in each hemisphere. For example, southern hemisphere summers tend to be a bit warmer and shorter because they coincide with perihelion. This complex interplay between Earth's tilt and its elliptical orbit shapes the unique climate patterns we experience year after year. Understanding this helps us appreciate why seasons don't simply follow Earth's distance from the sun, but are a beautiful result of celestial mechanics working together. Impact on solar energy received. Ever wondered how much difference the sun's distance really makes to the energy Earth receives? At perihelion, Earth is about 7% closer to the sun than at aphelion, meaning it absorbs noticeably more solar energy. This increase might seem small, but it actually translates into a significant boost in the amount of sunlight hitting our planet's surface. This extra energy can influence weather patterns and temperature variations, especially in the southern hemisphere, which experiences summer during perihelion. The increased solar radiation can lead to warmer summers and slightly shorter winters there. Conversely, during aphelion, Earth receives less solar energy, which can contribute to cooler temperatures and longer winters in the northern hemisphere. However, this difference in solar energy is just one piece of the climate puzzle. The tilt of Earth's axis and atmospheric conditions play much larger roles in shaping our seasons and weather. Still, the variation in solar energy between perihelion and aphelion subtly affects global climate systems, influencing phenomena like monsoons, ocean currents, and even the timing of plant growth cycles. Scientists closely study these energy fluctuations to improve climate models and predict long-term changes. So, while Earth's distance from the sun isn't the main reason for our seasons, it quietly fine-tunes the climate, reminding us that even small cosmic shifts can ripple through life on Earth in fascinating ways. Influence on climate patterns. The subtle dance between Earth's distance from the sun and its climate patterns is more intricate than most realize. While the difference in solar energy between perihelion and aphelion is about 7%, this variation can subtly influence weather and climate systems across the globe. For instance, the southern hemisphere, which experiences summer during perihelion, tends to have slightly warmer and shorter summers compared to the northern hemisphere. This difference affects atmospheric circulation patterns, ocean currents, and even the timing of seasonal events like monsoons. The extra solar energy during perihelion can intensify weather phenomena, leading to shifts in rainfall and temperature distributions. Conversely, during aphelion, the reduced solar input in the northern hemisphere's summer can contribute to milder conditions. These subtle shifts, when combined with other climate drivers like ocean cycles and atmospheric composition, help create the complex and dynamic climate system we experience. Scientists study these effects closely, using data from satellites and climate models to understand how small changes in Earth's orbit influence long-term climate trends. This knowledge is crucial for predicting future climate scenarios and understanding natural climate variability. So while perihelion and aphelion don't dictate the seasons outright, their influence gently shapes the rhythms of Earth's climate, reminding us that even minor cosmic variations ripple through our planet's environment in fascinating ways. Earth's orbital speed differences. So, Earth's speed as it orbits the sun isn't constant. It actually changes depending on how close or far it is from the sun. When Earth reaches perihelion, the closest point to the sun, it zips along faster due to the sun's stronger gravitational pull. This increase in speed is a direct consequence of Kepler's laws of planetary motion, which explain that a planet moves quicker when it's nearer to the sun and slower when it's farther away. Conversely, at aphelion, Earth moves more slowly because the sun's gravitational grip weakens with distance. Now, this variation in orbital speed affects how long each season lasts. For example, the northern hemisphere's winter is shorter because it coincides with perihelion when Earth is moving faster. Meanwhile, summer in the northern hemisphere lasts longer as it occurs near aphelion when Earth's pace slows down. This subtle difference in orbital velocity influences the rhythm of our year and the timing of seasonal changes. Understanding these speed shifts helps scientists refine climate models and predict how Earth's orbit interacts with other celestial forces. It's a remarkable reminder that Earth's journey around the sun is a dynamic, ever-changing dance governed by gravity and motion, shaping the very experience of time and seasonality on our planet. Historical changes in orbit. So, Earth's orbit isn't, fixed in stone. It actually changes slowly over thousands of years, mainly because of gravitational tugs from other planets, especially those massive ones like Jupiter and Saturn. These gravitational forces cause Earth's orbit to shift in both shape and orientation. and this whole process is called orbital eccentricity. Over really long timescales, this means the distance between Earth and the Sun at perihelion and aphelion isn't always the same, but instead, it varies in a pretty predictable cycle. These slow changes can have some pretty profound effects on Earth's climate, even contributing to natural cycles like the ice ages. When Earth's orbit becomes more elliptical, the difference between perihelion and aphelion grows, which actually amplifies those seasonal contrasts we feel. On the flip side, when the orbit is more circular, the seasonal differences tend to be a lot milder. This orbital variation, combined with other factors like axial tilt and precession, creates these really complex climate patterns over tens of thousands of years. Scientists study these cycles to help understand past climate changes and to predict future trends too. The shifting orbit also affects the timing of perihelion and aphelion, so these points actually move through the calendar gradually over millennia. This ongoing cosmic dance just highlights how dynamic our solar system is, and how interconnected planetary motions really influence life here on Earth. Understanding these long-term orbital changes honestly deepens our appreciation for the delicate balance that sustains our planet's environment, and it's a reminder that Earth's place in space is always evolving. Perihelion and aphelion in other planets. Not all planets orbit the Sun in perfect circles and, well, Earth is no exception. Just like our planet, other planets also have those points in their orbits called perihelion and aphelion, the closest and farthest distances from the Sun. But these distances can vary dramatically depending on each planet's unique orbit. For instance, Mercury, which is the closest planet to the Sun, has a highly elliptical orbit, so its perihelion and aphelion distances are really different, causing some extreme temperature swings. On the other hand, Venus has a nearly circular orbit, so its distance from the Sun barely changes throughout the year. Then, gas giants like Jupiter and Saturn have much larger orbits, so their perihelion and aphelion points are millions of kilometers apart, but the relative difference compared to their average distance is actually smaller. These variations affect each planet's climate, atmospheric conditions, and even the length of their years. By studying perihelion and aphelion across the solar system, scientists can better understand planetary climates, orbital dynamics, and how gravitational forces shape planetary paths. It also gives us insight into how Earth's orbit compares to others, really highlighting the delicate balance that sustains life here. This cosmic perspective is a good reminder that while Earth's orbit might seem unique, it's actually part of a vast interconnected system where every planet's journey around the Sun tells its own fascinating story. Why understanding these points matters. Understanding Earth's perihelion and aphelion isn't just about, distances and dates. It's actually a key to unlocking how our planet's climate and environment work. Scientists rely on really precise knowledge of these orbital points to improve climate models, which helps predict weather patterns and long-term climate changes. Satellites and space missions also benefit from this understanding, since accurate calculations of Earth's position relative to the Sun are crucial for navigation and communication systems. The subtle shifts in Earth's orbit influence everything from ocean currents to atmospheric circulation, shaping the conditions that sustain life. Plus, studying perihelion and aphelion deepens our understanding of celestial mechanics, showing just how gravitational forces govern planetary motion with incredible precision. This knowledge doesn't just stay on Earth, it also helps us explore other planets and their environments. By appreciating these cosmic rhythms, we gain insight into the delicate balance that keeps Earth habitable. It's a reminder that our planet's journey around the Sun is not just a simple orbit, but a complex dynamic dance with effects on our daily lives and our future. Engaging with these concepts connects us to the broader universe, inspiring curiosity and respect for the forces that shape our world. Thanks so much for joining us on this cosmic journey through Earth's perihelion and aphelion. If you enjoyed diving into these fascinating space facts, don't forget to hit that subscribe button and ring the bell icon so you never miss an update from Space Facts. We absolutely love hearing from you, so go ahead and drop a comment below with your thoughts or any questions you might have about our planet's orbit or really anything space-related. Your curiosity is what keeps this channel alive and thriving. Until next time, keep looking up and stay curious. Mars is closer to becoming humanity's second home than ever before. In the year 2025, multiple missions are actively exploring the planet, uncovering secrets that could change everything we know about life beyond Earth. Here's a powerful fact. Mars has the tallest volcano in the solar system, Olympus Mons, standing nearly 3 times the height of Mount Everest. This giant peak tells a story of a planet shaped by intense geological forces. Did you know this incredible feature exists on our neighboring world? Mars missions in 2025. Mars in 2025 is no longer just a distant dream but a dynamic frontier buzzing with activity and innovation. This year marks a pivotal moment as multiple missions, both robotic and preparatory for human arrival, are in full swing. NASA's Perseverance rover continues to send back invaluable data, analyzing Martian soil and searching for signs of ancient microbial life, while China's Tianwen-1 mission expands our understanding of Mars's atmosphere and surface. Meanwhile, private companies like SpaceX are pushing the boundaries with their Starship program, aiming to make human travel to Mars a reality within the decade. Advances in artificial intelligence and robotics have revolutionized how these missions operate, allowing rovers and landers to perform complex tasks autonomously, overcoming the communication delays between Earth and Mars. The year 2025 also sees unprecedented international collaboration, with agencies from Europe, Russia and the UAE joining forces to share resources and expertise, accelerating our collective progress. These missions not only gather scientific data, but also test new technologies for sustainable living on Mars, such as habitat modules and life support systems designed to withstand the harsh Martian environment. The excitement is palpable because each discovery brings us closer to answering profound questions about life beyond Earth and our future as an interplanetary species. Mars in 2025 is a testament to human curiosity and determination, setting the stage for the next giant leap in space exploration. What's happening on the Red Planet right now isn't just history in the making, it's the foundation for humanity's future among the stars. Technological advances. The technology powering Mars exploration in 2025 is nothing short of revolutionary, transforming how we study and prepare for life on the Red Planet. Gone are the days when rovers were simple remote-controlled machines. Today's explorers are equipped with cutting-edge artificial intelligence that enables them to make decisions independently, navigate treacherous terrain, and conduct experiments without waiting for instructions from Earth. This leap in autonomy is crucial because the communication delay between Earth and Mars can stretch up to 22 minutes one way, making real-time control impossible. Advanced robotics now handle complex tasks like drilling beneath the surface to collect samples, analyzing soil chemistry, and even assembling habitat components designed for future astronauts. Communication technology has also seen a massive upgrade, with laser-based systems promising faster and more reliable data transmission, allowing scientists to receive high-resolution images and detailed findings almost in real time. Additionally, innovations in power sources such as improved nuclear batteries and solar panels optimized for Mars's dusty environment ensure these missions can last longer and perform more ambitious tasks. The integration of virtual reality and augmented reality tools is also helping mission planners and engineers on Earth to simulate Mars conditions with incredible accuracy, refining every step before it happens millions of miles away. All these technological advances don't just push the boundaries of exploration, they lay the groundwork for sustainable human presence on Mars. In 2025, technology isn't just supporting missions, it's redefining what's possible for humanity's next giant leap into the cosmos. Mars colonization efforts. Human colonization of Mars in 2025 is shifting from science fiction to serious groundwork, with bold plans and groundbreaking tests shaping the future of interplanetary living. SpaceX's Starship program is at the forefront, making rapid progress toward carrying the first humans to Mars within the next few years. These efforts are not just about reaching Mars, but about creating sustainable habitats where people can live and work long-term. Engineers and scientists are testing life support systems that recycle air and water, advanced greenhouses to grow food in Martian soil, and radiation shielding to protect settlers from cosmic rays and solar storms. NASA's Artemis program, while focused on the Moon, is also playing a crucial role by developing technologies and strategies that will be adapted for Mars missions. Meanwhile, space agencies worldwide are collaborating on building infrastructure like landing pads, communication networks, and energy sources that future colonies will rely on. The challenges are immense. Mars' thin atmosphere, extreme temperatures, and isolation demand innovative solutions. But every test and prototype in 2025 brings us closer to turning Mars into a second home. What's thrilling is that this isn't just about astronauts in spacesuits. It's about creating a new society, with all the complexities that come with it, from psychology to resource management. The dream of humans living on Mars is no longer a distant fantasy, but a rapidly approaching reality, fueled by relentless ambition and cutting-edge science. In 2025, Mars colonization efforts are laying the foundation for humanity's boldest adventure yet. Scientific discoveries. Mars continues to surprise scientists in 2025 with groundbreaking discoveries that, honestly, reshape our understanding of the planet's history and its potential for life. Recent data from rovers and orbiters have revealed these really complex geological formations that hint at a wetter, more dynamic past than we ever imagined. Sedimentary layers, ancient riverbeds, and mineral deposits all suggest that Mars once had vast oceans and lakes, creating environments that could have supported microbial life. In 2025, researchers are analyzing organic molecules found in Martian soil samples, and that's sparking some lively debates about whether life ever existed there. These findings aren't just scientific curiosities, they could actually answer one of humanity's oldest questions: are we alone in the universe? Additionally, the discovery of methane spikes in the atmosphere continues to intrigue experts, since methane can be produced by both geological and biological processes. Figuring out its source could unlock clues about current or past life beneath the surface. Mars's diverse terrain, from those towering volcanoes to deep canyons, is also being studied in unprecedented detail, revealing how volcanic activity and climate shifts shaped the planet's evolution. Each new discovery adds pieces to the puzzle, helping scientists prepare for future human missions by identifying safe landing sites and resource-rich areas. The excitement in 2025 is honestly palpable, because every breakthrough brings Mars closer from a distant world to a place we might actually one day call home. Exploring Mars isn't just about science, it's about discovering our own origins and possibilities in the vast cosmos. Water on Mars. Water on Mars has become the hottest topic in 2025, and for good reason. Finding accessible water is the key to unlocking Mars's potential for life and human settlement. Recent missions have confirmed that vast reserves of water ice lie hidden beneath the planet's surface, especially near the poles and in some mid-latitude regions. But what's truly exciting is the growing evidence that liquid water might occasionally flow on the surface, even if just briefly, during those warmer seasons. This discovery really challenges long-held beliefs about Mars being a completely dry world, and it opens up new possibilities for sustaining future explorers. Scientists are also investigating how to extract this ice efficiently, turning it into drinkable water, breathable oxygen, and even rocket fuel by splitting water molecules. This could drastically reduce the need to transport resources from Earth, making Mars missions a lot more feasible and cost-effective. Moreover, understanding the water cycle on Mars helps researchers predict weather patterns and seasonal changes, which is crucial for planning safe human activities. The presence of water also fuels the ongoing search for microbial life, since water is essential for all known life forms. In 2025, every drop of water discovered on Mars isn't just a scientific breakthrough, it's a lifeline for humanity's ambitions beyond Earth. With water now more than just a distant hope, Mars is steadily transforming from a barren desert into a world teeming with potential for discovery, survival, and maybe one day, thriving human communities. Mars' atmosphere and climate. Mars's atmosphere in 2025 remains one of the most fascinating and challenging aspects of exploring the red planet. Unlike Earth's thick, life-supporting blanket of gases, Mars has a thin atmosphere composed mostly of carbon dioxide, with just traces of nitrogen and argon. This thin layer means surface pressure is less than 1% of Earth's, making it impossible for humans to breathe without assistance. But what's really captivating in 2025 is how scientists are unraveling the mysteries of Mars's climate and weather patterns. Dust storms, some of which can actually engulf the entire planet for weeks, continue to pose a major obstacle for solar-powered missions and future colonists. These storms can drastically reduce sunlight, affecting energy supplies and visibility. Researchers are closely monitoring temperature fluctuations that swing wildly from blistering heat during the day to freezing cold at night, demanding innovative solutions for habitats and equipment. Recent data also show seasonal changes in atmospheric gases, hinting at active geological or even biological processes beneath the surface. Understanding these atmospheric dynamics is absolutely crucial for planning safe landings, designing protective gear, and predicting weather conditions for astronauts. In 2025, every insight into Mars's atmosphere brings us closer to taming this alien environment, turning a hostile world into a place where humans might one day thrive. The red planet's climate may be harsh and unpredictable, but it's also a puzzle that fuels our curiosity and determination to explore further. International collaboration. International collaboration on Mars exploration in 2025 is reaching unprecedented levels, proving that space truly unites humanity beyond borders. Space agencies from Europe, Russia, China, the UAE, and the United States are pooling their expertise, technology, and resources to tackle the immense challenges of reaching and studying Mars. This global teamwork accelerates progress by sharing data, coordinating mission schedules, and jointly developing new technologies. For example, the European Space Agency's ExoMars mission works closely with NASA's Perseverance rover, combining their scientific instruments to maximize discoveries. Meanwhile, private companies from various countries contribute innovative spacecraft designs and launch capabilities, making Mars missions more affordable and frequent. This cooperation extends beyond just hardware. Scientists and engineers across continents collaborate in real time through virtual platforms, analyzing samples and planning future missions together. The benefits are clear. By working as a united front, the international community can overcome technical, financial, and logistical hurdles that would be insurmountable alone. In 2025, Mars exploration is not just a race, it's a shared journey that reflects humanity's collective curiosity and ambition. This spirit of collaboration also sets a powerful example for solving Earth's problems, showing how global challenges can be met with unity and innovation. As we push further into the cosmos, the partnerships forged today will be the foundation for sustainable human presence on Mars and beyond. The story of Mars in 2025 is as much about cooperation as it is about discovery, reminding us that when we reach for the stars, we do it together. Challenges in Mars exploration. Mars exploration faces some of the toughest challenges humanity has ever encountered, and well, 2025 is no exception. One of the biggest hurdles is radiation. Without Earth's protective magnetic field, astronauts and equipment on Mars are exposed to dangerous cosmic rays and solar particles that can damage DNA and electronics. Engineers are, racing to develop effective shielding technologies, from advanced materials to underground habitats, to keep future settlers safe. Another persistent challenge is Mars's infamous dust storms, which can last for weeks and cover the entire planet, blocking sunlight and disrupting solar power systems. These storms also pose risks to machinery by clogging joints and sensors with fine dust. Communication delays between Earth and Mars, which can stretch up to 22 minutes one way, make real-time control impossible, forcing rovers and landers to operate autonomously, a complex feat requiring sophisticated AI. The thin atmosphere and extreme temperature swings, from scorching days to freezing nights, demand robust life support systems and habitat designs that can withstand these harsh conditions. Even the psychological effects of isolation and confinement on astronauts are a major concern, prompting research into mental health support for long-duration missions. Despite these obstacles, every challenge tackled in 2025 pushes us closer to sustainable human presence on Mars. These difficulties don't just test technology, they test human resilience and ingenuity, proving that with determination and innovation, no frontier is too daunting. Mars exploration in 2025 is a story of overcoming the impossible, one challenge at a time. Mars sample return missions. Mars sample return missions in 2025 are among the most ambitious and eagerly anticipated projects in space exploration. For the first time, robotic spacecraft are not only collecting soil and rock samples, but preparing to send these precious pieces of Mars back to Earth for detailed analysis. This monumental effort involves complex coordination between orbiters, landers, and rovers working in perfect harmony. The samples hold the key to unlocking Mars's secrets, offering clues about its geological history, climate evolution, and the tantalizing possibility of past life. Unlike remote analysis, bringing Martian material to Earth allows scientists to use the most advanced laboratory equipment, far beyond what can be sent to Mars, to conduct experiments with, honestly, unparalleled precision. The The technical challenges are enormous. The spacecraft must safely collect, store, and launch the samples into orbit around Mars, where another spacecraft will capture them for the journey home. Success in 2025 would mark a historic first in interplanetary sample return, paving the way for future missions that could bring back even more diverse materials. This mission also tests technologies essential for human exploration, such as precision landing and autonomous rendezvous in space. The excitement surrounding these missions is palpable because they represent a giant leap in our quest to understand Mars not just as a distant world, but as a place that once might have harbored life. In 2025, the dream of holding a piece of Mars in our hands is closer than ever, promising to revolutionize planetary science and inspire generations to come. Future outlook beyond 2025. Mars exploration beyond 2025 is shaping up to be an era of bold ambitions and groundbreaking breakthroughs that could, really redefine humanity's place in the cosmos. Plans are already underway for more advanced missions that aim not just to visit Mars but to establish a lasting human presence. Concepts like building self-sustaining colonies, mining Martian resources, and even terraforming parts of the planet are moving from theoretical discussions to serious research and development. Space agencies and private companies are designing next-generation spacecraft capable of faster travel, larger payloads, and safer landings. Technologies tested in 2025 will evolve, enabling astronauts to live longer on Mars, with minimal reliance on Earth. Beyond technology, the focus will shift to creating the social, psychological, and economic frameworks needed for life on another planet. Everything from governance and communication to education and healthcare in space. Meanwhile, robotic explorers will continue to scout new regions, searching for resources and uncovering Mars' secrets in greater detail. International cooperation is expected to deepen, with joint missions and shared infrastructure becoming the norm. The challenges remain daunting: radiation, dust storms, and the sheer distance from Earth. But the momentum built in 2025 promises a future where Mars is not just a destination but a new home. The excitement lies in knowing that what we start now will shape the next century of exploration and discovery. Mars Beyond 2025 is a story of human resilience, innovation, and the unyielding desire to explore the unknown, pushing us ever closer to becoming an interplanetary species. Thanks for joining us on this incredible journey through Mars in 2025. If you loved diving into these fascinating facts about the Red Planet, don't forget to hit that subscribe button and ring the bell icon so you never miss an update from Space Facts. We want to hear from you. Drop a comment below sharing your thoughts or questions about Mars and space exploration. Your curiosity fuels our mission to bring the universe closer to you. Stay curious, and we'll see you in the next video.